Okay, so this is what I have been working on for the past few months. One of my biggest gripes, if not the only gripe with the GameCube, is that like most modern consoles today, you cannot power it from the controller. Every time you want to turn it on, you have to do it from this button right here. So my goal was to make that not the case. I want to be able to power on the GameCube wirelessly. So I decided to take a Wavebird, a couple of Arduinos, and a custom-made PCB, and try to accomplish that goal. So right now I have a copy of the Go in, so we'll close that. And then this right here is just for demonstration purposes. You could make this permanent. You just need to do some kind of modification to the outer shell of the case for the Wavebird. So I will demonstrate this now. I'll kind of take this controller and walk away, and then I'm pressing the button now. And there it is. And then now I'll press it again to get it to turn off. Pressing it. And there you go. So one of the tricks to this was, of course, trying to get this to work in tandem with the actual power button. So as you can see here, I have it working to where if I press this power button, you will also get power on and off. And these work together as well. So if I power it on from here, I can also power off from the controller. Just like that. Okay, so I was about to disassemble this, but then I kind of realized that I should probably document some of the more specific details about my design. So getting into it, I'll take this back cover off, and it's definitely not very elegant. I'll say that much. There's definitely a lot of work that still needs to be done. It did work out, but this wire configuration definitely had to have some kind of more elegant solution than what it is currently dealing with right now. So I guess we'll start with the very beginning, and that would be with this terminal here where the GameCube actually receives power from the wall jack. So this is the first place you kind of have to work on if you plan on doing this. So as you can already see, there's some pretty heavy modification that needed to be done in order to actually get this to work. So right here is the button that was used to send a signal to the Arduino that is inside of here. That way we can continue to use the onboard power switch and not have to depend on the wireless power switch entirely. So moving past that, we also had to do some modifications to the inside of the power button. I needed some more space. So you can see I kind of added a piece of circuit board there to kind of bridge the gap between that button and the rest of the GameCube. So opening this up, you'll see the first thing is that I have two wires coming off of the power supply here, and I color coded them so that I knew which was positive and which was negative, and that was later used to power the Arduino, which I will get to in a second. But where it really kind of gets ugly is the inside of this mechanism here. And as you can see right there, there is a little gold contact. And this is usually what is responsible for bridging the gap between the voltage return line. So that gold portion is what you're pressing down into the contacts when you turn on the GameCube. Right now, I have that permanently soldered to each end, so it's almost as if the power is on all the time. However, at a later point, I actually am intercepting the voltage return from both the fan and the actual console itself with these two lines. It's very difficult to see, but basically I'm taking two wires and splitting them and then intercepting that connection. Once we send that or get that connection from the GameCube's voltage return line, we send it to this transistor right here, which is basically just like a switch almost. This pin here on the transistor comes out of the Arduino, and at some point, if I send voltage to that pin, it will allow current to flow through the other two legs, basically doing what was done with the mechanical switch in a virtual way. So that's that. As you can see here, this is the receiver. So this is what would be responsible for kind of getting the signal from the Wavebird. So it gets that, and then we send that to the Arduino, to the data line. And then the last major component of this is the voltage regulator. So when you take these two pins directly off the power supply from the GameCube terminal on that side, these two pins, they're going to be at 12 volts. And if you don't have that voltage regulated down to 5 volts, it'll fry these little Arduino boards. They're supposed to have an inboard or onboard regulator, but I tried that the first time and I ended up frying a capacitor. So I do not recommend relying on that. So the voltage comes in through this voltage regulator, goes to the Arduino, and then once a signal is received, the receiver will tell the Arduino, and the Arduino will tell the transistor to allow current to pass through, and that is what completes the circuit. So I had to do a lot of research on a lot of these parts, and a bunch of work went into this, but it is overall not too complicated. The hardest part for sure was just getting it all to fit in the case and doing it in an elegant way. Again, definitely not a very efficient design. If I had to do it again, I wouldn't go this method. I would try to keep the switch stock as much as possible, but it would be tough because if you wanted to turn the console off by means of wireless communication, it would make it much more difficult. So I couldn't think of a way to include the mechanical operability of the current switch, but maybe that's something I can work on in the future. The last thing here is just that you kind of have to make some minor case modifications for this to work. I had to take a Dremel tool and kind of cut down this leg here, as well as a few different nubs that need to be grinded down with some kind of sanding tool. But yeah, overall not too bad. And I think that pretty much covers all of the stuff I did with this project. Of course, there's a little bit of code that had to be written, but that was pretty easy. Once you learn the Radiohead library that these are functional with, the rest is pretty much a breeze. So yeah, the reason why I had this circuit board is just because it was impossible to get this entire assembly to work without these wires either confusing me because there's so many. Shorting out to ground was another thing, or shorting on each other was huge too. So this kind of made it a lot simpler. And yeah, I just have, the last thing I guess I'll say is that this resistor here is just a pull down resistor, just so that there's no interference, that this button here is being pulled down to 0 volts. Basically I'm running current into the switch, and then when I press the switch, current is allowed to flow to the other, through the other wire. That current goes back to this. And when A0, this pin here, receives 5 volts, it will tell the transmitter to allow current to flow or turn off, depending on the current status of the power. So yeah, that's pretty much all of the major components of this design. So yeah, I will link the PCB and the parts I used in the description. If you have any questions, feel free to DM me or leave a comment.